All right, hello everyone, this is Mr. Crozier. I want to give you some quick hints on Chapter 5, Practice Test A. So here we go. Problem number 1, make the graph over the domain. The domain is the inputs, so you have to do this work right here. That is domain. And this is a non-calculator problem. So when you plug in -3 here, you get 1/2 times 2 to the -3 plus 1. Well, that's 1/2 times 1/8 plus 1. That's 1/16 plus 1. That's 1 1/16. So use that number right there. If you're going to graph, it's easier to graph that. If you want to, you could do that, but that's a little bit harder to graph. And don't use decimals. Solve each. Get these the same bases. This is 2 to the x minus 3. This is 2 to the 4th. Drop those. Same bases here, 5 to the -1, or sorry, it's already 5 to the x. And then think about this, what exponent do I need here to turn it into there? There's two separate formulas for this. When you do continuous, it is this formula. When you do anything else, the monthly one, it is this formula. Principal 1 plus the rate divided by 12 times the time times 12. So there are two different formulas. Monthly, 12 and 12. Continuously, you're using that formula. One shortcut here is if you have a 5 log here, those are gone and you're left with 7. You can do that. This one here, I would rewrite it. 3 to the 4th is that. Solve each one here. Again, move stuff over. And let's do this one. If you add 1 and divide by 2, you're here. And now if you take the natural log of both sides, it should come out nicely. Same thing here. You're going to put this over, and well, I'll show you one thing here. If you put this over, you're at 30, and if you divide that over, you're here, and you're at 15. One thing to do here would be to take the log of both sides, but don't do ln. Do this. Log base 6 of 15. Because that's just 1. And if this makes sense, do that. If that doesn't make sense, take the natural log. This is supposed to be a D here. What's the diameter when there are 21 trees? We'll put 21 over here. Solve that equation, and it's going to take logs to get that down. On the next one, solve each equation. Well, what I would do is after I put this over there, I would leave the world of logarithms. This is base E. Leave the world of logarithms and just go e to the 10^3 equals 5x. And this is a calculator problem. So try to do it that way. When you do this one, it's easier if it's a 0. So on the new versions, I made it 0. If it's not 0 on yours, put it to 0. But what this means right here is you have these two things being multiplied together inside a log. So they're multiplied together because the logs can combine through the addition. Once you're there, put an E, rewrite it. This is going to take the quadratic formula to solve. The equation here, well, if you look at it right away, there's the axis, so I know my p-value is 5. Now you're going to have to plug in a point to find the rate here. I made a video. There's a complete video explanation for this one right here. This is the hardest problem on the test. Very difficult. I made a video separately for this one. On this one, find x when f of x is 18. So the output is 18. So you just need to find the input that gives that. And that's going to take drawing a line, doing some algebra, taking a log, bring that down. Plug in these points here. Should be able to do it without a calculator, and I'll give you a clue. Exponential graphs go up like this. This is an exponential graph, but a logarithm graph looks like this. So your graph's going to look like this. And the thing to see here is that they are reflections. See this graph over here? This graph over here is an exponential graph. It goes up. But when you do a log graph, it is reflected over this line. So this is what our graph's going to look like. This is a graph of a log. This is a graph of an exponent. And they're flipped about that line. How do we do this one? Well, a lot of people get stuck on the very first step. Well, the very first step is to make it two fractions and cross multiply. This times this equals that times that. And now you have a typical problem. Divide the 5, subtract the 8, take the log. Going on to this one. This is a straight calculator problem. F of root 6 is equal to 7, 3 root 6. Type it in your calculator. See if you can get the decimal to match. Car is continuously decreasing. Well, that's your formula. Well, it tells you the principal. E value. It tells you even the rate, but just make sure you put it, say, negative 17, because it's decreasing. So use this formula, half its value. If it's 20,000 now, we want it to be down to 10,000. So solve that equation, again with some logs. Straight calculator problems. Type them in your calculator, as is if you can. This one you can't, so what you do is you change it to log 8 on top divided by log 3 on the bottom. That will give you the answer. And then that's a simple problem with a calculator. It's just log 8 divided by log 3. 1.89 about. Your calculator won't do it in this version, so you change it to this version. You make them both 10, so this is really 10 and 10, and those are the same. So that's what your calculator wants. It wants it like this. Your calculator doesn't accept that. These ones you can type in. Couldn't you just change this to log 9? And then your calculator will do that because your calculator does base. Expanding them, pull them apart. If we have 5 squared times 5 to the 7th, that's 5 to the 9th. Addition, multiplication go together, so just break this up into log 5 plus log x cubed plus log y. And then now one last step is that this 3 can come down, and then this is fully expanded. Put these together. This 2 can become an exponent. So this is ln of 4 squared plus ln of 2 minus ln of 16. And 4 squared is 16, so this becomes this. And now look what I can do here. Whoops, it should be fairly obvious. This is ln of 16 minus an ln of 16, so they're gone. And that is just ln of 2. You can check that on a calculator, right? Let's try this. I have ln of 2. Is that decimal 0.6931. Now watch this. Let me put this original function in here. 2 ln 4 plus ln 2 minus ln 16. Hey, and we're right back to where we started from. That's what simplification is about. It's about taking this, which is rather long, and putting it into its most simplest form here. All right, first step on this problem is to make that base e, and that's e to the 1/2 equals the third root. I'm going to write third root like this because that's what third root means. Third root means it's the 1/3 power. And now my algebra step to undo all this is to do to the third power, because 3 times 1/3 is just 1, and now I'm just at that. And this times this is e to the 3/2. Solve for x, minus this over there, e to the 3/2 minus 3. And that is an answer. This is a non-calculator problem. If you wanted a decimal, it would be e to the 3/2 minus 3 is about 1.4817. However, this was a non-calculator problem. 18. Put a 10 there. 10 to the negative 2 equals that. Do some algebra. Number 9, you deposit that into an account that pays 1.5 interest compounded quarterly. How many years will it take for your money to triple? Well, here's my equation. 4500 times 1 plus my interest rate divided by 4, and 4 times t. How many years do I plug in there to do this math to get this? Let's see here, triple to turn into that. Well, now it's an equation to solve and draw a line, take a log to get that down. Find the exponential model for this. Well, hey, there's my starting value, so y is equal to 2, because that's the start, and e, b to the x. Figure out b. Well, how are you going to do that? You're going to drop a line. You're going to plug in this point. You're going to put a 4 up here, 2e b times 4 and 3, and solve that for b. You can round this to 4 decimals. That will be enough. Right there. And again, how are you going to get that exponent down? Well, that's kind of the whole idea of this whole chapter is exponents can be brought down by doing the inverse of that, which is a logarithm. So it's going to involve a log here somewhere to solve for that. You can get it to 4 decimals. All right, hope this helps with your practice test A.